Guys, Zol here, and today I want to explore some of the darker pasts of the field of chemistry, specifically a man named Thomas Midgley Jr., otherwise known as the one-man walking climate disaster. Midgley Jr. is best known for his work in popularizing the use of leaded gasoline and chlorofluorocarbons, the chemical compounds that depleted the ozone layer. Today, I want to kind of explore what the uses of leaded gasoline and CFCs were and why they were so bad for the environment and why they were used for so long despite their terrible impacts on the health of the world. So stick with me, you'll probably learn some cool facts. Be sure to comment and like the video, and let's hop right into it. The first thing I want to talk about are CFCs, chlorofluorocarbons. These were halogenated alkane compounds that were used as refrigerants to replace previously used toxic chemicals that were used as refrigerants. They needed to be non-toxic and have a low boiling point. And CFCs actually worked wonderfully at what they were designed for, but there was some impacts that were not known at the time, and by the time CFCs were widely adopted, the damage had already been done. Because as it turns out, as CFCs get into the upper atmosphere, which is populated by ozone that, as we know, blocks UV radiation and makes Earth a much nicer place to live for all of us on the surface, what would happen is the UV radiation would be able to hit these carbon halogen bonds, which, as you know, if you've taken organic chemistry, can sometimes be unstable, and it would cause homolytic cleavage, which basically a ray of this UV radiation would snap a bond in half. And instead of having single lone pairs, this causes free radicals where there's just a single unstable electron attached to each molecule or atom bond that's there. And what these do is they're extremely reactive, and they went through and caused massive chain reactions that reacted with ozone and caused the depletion of the ozone layer, which is a massively important protective layer in the upper atmosphere for life on Earth. The good thing is CFCs have been slowly but surely phased out through the course of their use, and the ozone layer is actually healing. The ozone is being replenished, so these aren't necessarily permanent effects on the world. Now, there was also a second terrible invention that Thomas Midgley Jr. was instrumental in popularizing, and that is leaded gasoline. Now, to understand leaded gasoline, we sort of need to understand how the engines on cars work, the internal combustion engine. There is a cylinder and a piston head, and gas and air is injected or basically put into that cylinder and ignited. The ignition causes the expansion of gases, which pushes the piston out, and this causes a mechanical movement that can be transferred through gearing systems to whatever motion you need, be it the wheels on a car or a propeller on a plane. Now, this is a very complicated system, and lots can go wrong with that much mechanical, chemical movement and at those high temperatures. And engines can experience something called engine knocking. This is what happens when, instead of the gases being ignited to push the piston forward and cause that mechanical movement at the right time, there is ignition or flame in the cylinder head at a random point and before that full stroke has completed inside the engine. And because it's not happening in sequence with how the piston wants to move, it is putting a lot of mechanical strain on the parts and can completely destroy an engine very quickly. This is something called engine knock. And the way to combat this is with higher compression rated fuels. If you ever go to the gas pump and you see octane ratings, those are the rating for a gasoline's compression in an engine. Because if you've ever done phase diagrams or thermo in chemistry, you'll know that there's actually temperature change and property change involved with the amount of pressure that a substance is under. You can actually have phases exist in a way that people normally wouldn't think would occur if they're under extremely high pressures. You can have stuff way past its melting point in solid form, and there's a lot of different forms of this just by varying the pressure of the atmosphere around it. So what happens is as that piston compresses, you can actually cause the gas to ignite too quickly if its compression rating isn't high enough. And this is going to cause engine knock. What you would need to do is you'd need to make a compound or add something to the gasoline that lets it withstand a really high pressure without getting hot enough that it will ignite on its own. And this is specifically for gasoline engines. In fact, diesel engines and jet engines actually work by the function of if you push something hard enough, it'll ignite. But basically, they discovered that tetraethyl lead, which was the additive that was put into leaded gasoline, would be an extremely effective additive to gasoline to remove engine knock. It raised the compression rating of the engine, so the engine could push harder on this air without letting the gas ignite, and this led to higher performance, more efficient engines, and so it became very quickly widely adopted. This worked by the fact that under the conditions inside a cylinder head, the tetraethyl lead would actually decompose really quickly. The lead would go off on its own, and each of the bits of the ethyl compounds, the ethyl part of tetraethyl lead, would separate, and they would react with the gas compounds that were in the cylinder head that were creating what was called a cool flame, where you basically have sort of the properties of fire at a much lower temperature without the normal properties that you'd see, like emission of light in a flame, and it would react with these like hot cool flame compounds and quench them basically, so the cylinder could compress fully and only be ignited by the spark plug. This was actually an extremely effective compound, and it works really well for what it was designed for. The issue is the part with lead. Because lead would be separated from these ethyl compounds very quickly and just turn into normal lead, you'd have this lead poisoning issue, especially when people are driving cars using gas pumps all the time. You would have lead everywhere. It was in the air, in the gas, and you also get the issue of tetraethyl lead being extremely effective at crossing the blood-brain barrier. So this lead could accumulate in the body very easily and very quickly, and lead affects the whole nervous system, the brain, etc., and can be very damaging. This was known as early as the very early part of the 20th century, where there were stories of the dangers of lead, people dying from this tetraethyl lead component of gasoline, and even being called loony gas because of what it did to the mind. But despite this actually wasn't phased out of automobiles up until the very end of the 20th century because it was so effective at raising the compression ratio of gasoline. And the fascinating thing that most people don't even know about this leaded gasoline compound is it's actually still in use today. It's not in our normal gasoline that you're going to get at the car pump, but in small piston aircraft, they still use leaded gasoline. It's a gasoline type called 100 LL or low lead, but it still contains a significant amount of leaded gas compounds, and partially this was phased in because reducing engine knock with an additive like tetraethyl lead increases the reliability and efficiency of an engine, which is very important in an aircraft where you don't exactly want engine knock and engine failure happening while you're flying. That being said, with modern technology, this is not necessary anymore. You can make engines reliable and powerful enough without these additives, and you can make a fuel that works well enough at a high compression to work in almost any application, such as piston aircraft. But because the slow adoption of regulations and pushback, tetraethyl lead is still in use in leaded gasoline of aircraft today. But I think this video is a really fascinating look into how breakthrough chemical discoveries and chemical compounds at the time can actually have very strong lasting climate impacts in the case of CFCs, or health impacts in the case of tetraethyl lead in lead gasoline, which is thought to have lowered an entire generation's average IQ point by a couple of points. And it's kind of an interesting aspect of all the good that can be done with chemistry, and also all the bad that can be done, even accidentally, by maybe well-intentioned people to try and fix problems in science, engineering, and society. And I think it's a really interesting view into also the character of Thomas Midgley Jr., who is perhaps the unluckiest chemist or chemical engineer alive in that 20th century period to have made these two massive breakthroughs in science that have had absolutely massive environmental impacts and were completely destructive to millions of people. But I hope you guys like the video. If you guys have any comments of any videos you want me to make, or any facts and tidbits about the subject area, be sure to let me know, and I'll see you guys next time.